Welcome to the continuation of bearings. In this video set, we want to look at series of questions in order to help us understand the concept we've already built from the previous videos. Now, because of the intensity of each question, I prefer using one video for one question so that the video wouldn't be so much lengthy for you to watch. And so in general, the objective is going to be that you should be able to solve series of questions involving bearings in general. And so video number 1 or example number 1 will be one video, example number 2 will be another video. So let's go straight to the point. Example number 1, we have a vector defined in the magnitude bearing form, and they want to find the bearing of P from Q. Now, if you've already watched the previous videos, this question wouldn't be a problem to you at all. So you can pause the video and give yourself a try. When you are done, you should get an answer of 170 degrees. Remember, you are to leave it to the nearest degree. So the answer will be very close to 170. When you run it off, you get 170. Now, let's look at the detailed solution of this. Now, the vector OP has been defined and the vector OQ has been defined, which means that O is an origin here, O is an origin here, and it means the vector or the bearing is going to be taken from O as the starting point. So if O is the starting point here, the first vector is vector OP, which takes from O as 140 degrees bearing. And so I'm going to take the north pole of O and measure 140 degrees. Then we draw our destination line to the point P. Now the next one also is OQ, which also starts from O to Q and is 50 degrees. So we want to take 50 degrees, then we travel to the point Q. Then also the line OQ has been defined as 4, and then OP was also defined as 7. Now we want to find the bearing of P by taking from Q. So the bearing of P taking from Q, that means we can join the 2 points together to have the point PQ. Then our bearing will be taken from the north pole of the Q right up to where the line that joined the 2 points. So this is what we want to calculate. Obviously, we know this angle is 90. So if we happen to know the remaining angle up to this point, then we can know the bearing as such. But that is not known. And the small angle here too, we don't know because there's no clue to that, to know that value. If you know the small angle here, of course, we can subtract that from 90 to get the remaining angle. So we need to apply knowledge from our lesson on Pythagoras theorem, our lesson on trigonometry in order to solve this. Now let's start from here. We know that the value over here, the angle here is 50, which means that the small angle here left for the red and the black line will be 40. Then also the whole of the angle 140 means that the small angle between the black and the mauve line here will be 50, which means the whole of this is 90 degrees. Hope that is clear. Now our target is to know this angle here. If I know the angle between the red line and then this blue line, of course I know that here is 40 based on alternate angle. So if I know the remaining angle here and I subtract that angle from 230, I'll get the bearing. I'm saying 230 because if here is 40, then the whole of the angle from the north pole up to the red line here will be 230 degrees. So if I know the remaining, if I know the angle from the red line to the blue line, then I can take that one from the 230, then I'll get all the angle right from here up to the blue line. That is what I want to do right now. So I need to find this angle. Hope it makes sense to say that. So I can draw this whole PQ POQ as a right angle triangle. Because of the 90 degrees here will be 90 degrees, and here is the origin O. Now from the O to P, the distance is 7, so I can put P here and put 7 there. Then O to Q, the distance is 4. Now the angle here represents the angle we have here, so that is the theta, so I can put theta here. That is what I want to calculate for. Don't forget that I said here is 40 degrees based on alternate angle. So with Pythagoras theorem, with trigonometry ratio, I can find the angle theta here, since this becomes the opposite and here becomes the adjacent. So I need tan theta to be equal to opposite 7 on adjacent 4. So tan theta will be equal to, if I divide 7 by 4, I think that will give me 1.75. Then I take tan inverse. I will take tan inverse of 1.75, and that will give 60.255. I don't want to approximate it to the nearest degree yet because I'm not done with the work. So that has given me the angle here. Now this is the angle I have. So I want to find the bearing right from here up to this point alone. But right up to the red line here, the angle is 230. We said that. The reason is that from the North Pole to the east to the south is 180. Then from the south to the west is 90, making 270. If I take this angle 40 from the 270, I have 230 here. Then I'm going to take the theta out of the 230 so that I'll get the remaining angle to be the bearing. And when I subtract 230 or 255 from 230, the result will be 169.745. And the question says we should leave our answer to the nearest degree, and this to the nearest degree will give us 170 degrees, and that was the answer we saw earlier on. I believe this is very good start. Quick review of what we are supposed to do. After drawing the diagram, our whole idea is to find the angle that lies between the North Pole up to this particular line. Now we know that right up from the North Pole up to where the red line here is 230. We've already established that. So all we needed was to find the theta here, the angle between the red line and then the blue line. So we can subtract that from 230 and get the remaining angle to be the bearing. And that is what we've gone through using the trigonometry ratio to solve. I believe it makes sense. Watch out for the next video for example number 2. Thanks for watching. You're welcome to example number 2 of the bearing series. And this question, we have a ship sails from port R on a bearing of 65 degrees to port X, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from the port S to port Q, a distance of 80 kilometers. We want to find to one decimal place the distance between R and Q, then the bearing of Q taken from R. So you can pause the video and try your hand on it. If you're able to do it, fair enough. Unable to do it, we shall all discuss it together. And if you're able to do it, your first answer supposed to be 96.5 kilometers. And the second one, that's the bearing of Q from R, will give you 121. Now let's go to the detail of this solution. Remember, a ship sailed from port R on a bearing of 65 to port X. That means we start from R, then we move on to X. So from the R here, we are moving on to X with a bearing of 65. So measure 65 from the North Pole, then we draw our line. Remember that we don't measure with protractor because this is not drawn to scale. So there's no need for you to use protractor to do this. Just draw a line to represent, or an angle to represent 65. Because in each case, you are doing calculations, not measurement. So we get to our destination, and that is X. And the distance for RS is given as 54. Then the question continues to say that it then sails, the ship then sails on a bearing of 155 from X. That means taking from the X pole here, we measure 155, or we draw 155 line, and then we move to our destination of Q. Right. So since we want to find the bearing of Q from R, but before then SQ was also given as 80 kilometers. So we now join the line between R and Q. We want to find the distance, also want to find the bearing. So how do we get a bearing? Normally, anytime you draw bearing and you get 3 points, check whether you can get 90 degrees in any of the interior angles, which of course will make it very easy to work with, because in that case you can apply trigonometric ratio to work with. But where you realize that none of the angles gives you 90 degrees, they need to apply cosine rule or sine rule. We'll take example of that sort later. So I know that we want to find the bearing of Q from R, and after joining the line, the bearing is going to be from the North Pole of R to the line that join R and Q. So we need to know this particular angle here, the angle here, and that will be very easy because here is 65, and so the remaining angle here is going to be 25. Then what about this angle also? If we know here to be 65, then using alternate angle, since the North Pole and the North Pole here are parallel, this line will serve as a transversal, and then here will be 65 degrees as well. And 65 plus 25 will be 90, so it means here is 90 degrees. That makes the triangle QXR to be right angled triangle. Now we want to find the bearing of Q, but reading from R here means we want to know the angle right from the North Pole up to the line blue. Of course, up to this move line is 65, so all we need is the remaining angle here so that we can add the two together to get our bearing. So we can put theta for that angle and calculate it using our trigonometric ratio. I can choose to redraw the diagram to look like this, so it's very easy to see. Here is the 90 degrees, and that represents our X. And then if here is 90 degrees here, then I'm assuming that the whole thing has been turned this direction, so R will come here and Q also move that way. Actually, you can choose to put any of them anywhere, but then you have to make sure the dimension given will be represented exactly. Now we know that S to R, that's S here to R, is given as 54, so I can put 54 here, and then here will serve as 80. Now the angle I want to calculate is theta at the point R here. So at the point R, theta is here. So whatever be the angle, I will just add it to the 65 to get a bearing. And so using tan theta again, tan is opposite 80 over adjacent 54. And so tan theta will be equal to 1.4815 to 4 decimal places. Then we find the tan inverse. So tan inverse of 1.4815 will be equal to 55.980. Right. And so That is our theta. Then we add it to, so our bearing of KO reading from R will be equal to 65 plus 55.980. And of course, finally, we can write our answer to be 120.980. So to the nearest degree is going to be equal to 121 degrees. That is for the second question. Well, you can choose to solve the first one first before the second, but I don't know why I chose to solve the second one first, because I'm much interested in the bearing, because that's the most difficult aspect. For the distance between R and Q is very easy because Pythagoras theorem can be of help to us there. So the first question, how do we solve it? We know that since here is 80, here is 54, and we want to find the distance between Q and R. If I put X here, then that becomes the distance between R and Q. And using Pythagoras theorem, of course, we can say S squared is equals to 80 squared plus 54 squared. And when you simplify and take the square roots, you end up getting 96. So you are going to get 96.5 kilometers to 1 decimal place. I think that was supposed to be done also over here. 1 decimal place will give us 0.0, because the answer was supposed to be 120.9, and to 1 decimal place we'll run this to be 121.0. so that 0 is very important to bring, because it will help you to have it as 1 decimal place. So that is how this solution or this question can be solved. I believe you did it well and had this answer. If not, then you can review the video once again to get a concept well understood. Thanks for watching.